Okay, so today we're going to be starting lesson 4-5 notes, which is nth roots, okay? So in math, when we say nth root, what that means is we're talking about a root of a number that we don't, know. So nth root means like the fifth root, the fourth root, the second root is what you guys are used to doing, a regular square root. So that's what nth means. It's what you're taking the root of. So radical vocabulary, we call this the index, the root that we're taking. So if we're taking the fourth root, we call it index 4, okay? What we take the square root or the root of, not necessarily a square root, but whatever we take the root of, we call it a radicand. And then, of course, this is the radical sign. You guys all know the radical sign. And then your answer comes out to be some number or some expression. And you can always put that back to the inverse power of your index to get back to your a value, which you guys know because we take the square root of something, we put it to the second power, it cancels out the square root. So let's talk about the different cases that can occur. So if you have an odd index, meaning that the radical you're taking is of an odd number like 3, you end up with one real root, okay, just one. And the example of that is, does anybody know what the third root of 8 is? What times what is 8? Number? 2. So the third root of 8 is 2. And does anybody know what the third root of -1 is? What times what is -1? Negative 1. So that's how you find a third root, and I'll explain that more as we go on. Now, we also have even, we have an even case where we have a radical of a positive real even. So this actually ends up with 2 answers. And you guys are used to this because we have plus or minus. That's where the plus or minus comes in. So what is the square root of 4? 2. But it's not just 2, it's plus or minus 2, right? Because -2 times -2 is +4, and +2 times +2 is also 4. And then lastly, anybody know what the fourth root of 16 is? So it's 4 numbers you multiply together that are the same number that'll give you 16. 2, exactly, good job. So it's not just 2, it's plus or minus 2, because you can multiply 4 negative 2's together and get 16, or 4 positive 2's together and get 16. And the last one we're going to talk about is even, where we have a square root of a negative number. So do we ever get any real solutions when we take the square root of a negative number? No, what do we call these?
Imaginary.
Very good, we call them imaginary. So we don't get any real solutions, we only end up with imaginary. And what is the square root of -4? Good, plus or minus, not -2, but 2i. You guys remember 2i? And then the fourth root of 16 is also plus or minus 2i as well. So that's that. Now we're going to just give some examples of perfect squares. So think of a number you know to be a perfect square.
64.
64, good. Any other ones? So 1 is a perfect square, right? 4. What else in this order? 3 to the second power is 9. 4 to the second power is 16. And then 5 to the second power, 6 to the second power, 7 to the second, and then, like Allie said, 8 to the second power, okay? So those are some perfect squares. So perfect squares is you take 2 numbers and multiply the same number together, and that will give you a number, okay? That's what suffices to be a perfect square. Now, as for a perfect cube, that's where you take a number and multiply it together 3 times. So if I do 1 times 1 times 1, what is that? 1. What's 2 times 2 times 2? 8. What's 3 times 3 times 3? 27. Anybody know what 4 times 4 times 4 is? 64. That's okay. 64. So you guys get the idea here. And then 5 times 5 times 5 is 125. And then these numbers go on and on, multiplying the same number together 3 times. So if perfect square is multiplying the same number, numbers that can be multiplied together 2 times, numbers where the product is the same number 3 times, what do you think a perfect fourth is? It's not a trap. What do you think? 4 times. So what's 1 times 1 times 1 times 1? 4 times. What's 2 times itself 4 times? Good. Anybody know what 3 times itself 4 times is? Well, 3 times 3 is 9.
81.
81, very good. So this just goes on forever, 4 times 4 times 4, and so on. You guys get the idea of what we're doing here? So those are perfect squares, perfect cubes, and perfect fourths. Those are the most common scenarios that you're going to see come up. These are the main 3. But there's also, you can do a 5th root and a 6th root and so on. But those are the most common. So let's go ahead and move into the next slide, which talks about simplifying radicals. So I am going to zoom in here so you guys can get a better view. So this takes you back to your days of simplifying radicals. We're going to start out simple, okay? Anybody know what the square root of 121 is? It is a perfect square. Yes. Well, 10 times 10 is 100, right? So what would be the next
11.
one? 11. Good, so this is plus or minus 11. Because remember, a regular square root is even, it's a square, okay? Now we're going to take the third root of 343, okay? So in this particular case, does anyone know what we can divide into 323 or 343? What? Well, you never know. But if you don't know it off the top of your head, that's a really good thing to bring up because typically you're not going to know this off the top of your head, right? So my suggestion is, I always recommend this to my students. You don't know what goes into it. I always divide it by numbers 2 through 9 until I find out which one works. Because usually one of those is going to work most of the time. So I go ahead and do that and I get 7. 7 times 49 would give me 343, okay? So then, moving on from there, what do you guys think for the next part? So we need to break this down more, right? What is 49 break up into? 7 and 7, very good. So with perfect squares, we usually have to group together pairs of 2. But what do you think we do for perfect cubes? Pairs of 3. If you can group it in, you do its prime factorization and you group it into a pair of 3. Okay? That means it gets to leave the radical. So this comes out to be 7 is your answer. Now, why is it not plus or minus 7? Yeah, because it's an odd root. Odd roots only have 1. You don't do plus or minus, only if it's an even root. So if it's like 2, 4, 6, 8, you know, and so on, then you would do plus minus. If it's odd, like 3, 5, you don't do one. So far so good? You guys understand it? All right, let's try the next one. So the next one we're looking at pairs of 4. We're trying to get a pair of 4. So I take 2,401 and I know it's divisible by 7. And when I divide it by 7, it breaks up into 7 and 343. Now 7 is a prime number, so I circle it. And then from previous experience with letter B, what do we know that 343 breaks up into? 7 and 49. And then of course we know that 49 breaks up into what? 7 and 7. Now if this is a 4th root, we need a pair of 4. Yeah, we need a group of 4. And if it gets grouped up in 4, we know it gets to leave as 1 of that pair. So the answer here is 7. So far so good? Makes sense? All right, let's try D. So this one is where it can be a little tricky because we have a negative. So what 2 numbers multiply together to give you a negative? A what and a what? A positive and a negative. So we know that this is going to be positive and negative. And we know that we need to group the same 3 numbers together. And when we group the same 3 numbers together, they need to have the same sign. So what times what would give me 125? Good. We're going to make the 5 negative, so we're going to negative 5 times a positive 25. It makes more sense to make the standalone prime number negative, and you'll see why. So that's negative 5 times positive 25. Everybody good with that? And then our goal is to get 3 of the same numbers. So what can I break up 25 into? 5 and 5, but we want it to be negative, so we can do negative 5 and negative 5, which would also give me a positive 25, right? So now, do I have a pair of 3 of the same numbers? So my answer here is negative 5. Very good. Makes sense so far? Okay. Alright, so the next one we're going to be looking at here is going to be the fourth root of 4,096. So I know that 4,096 is divisible by 8. So this breaks up into 8 and 512. So you can break up the 8, but sometimes you want to wait and see because you can sometimes pair things together without doing more work for yourself. So a good thing to check is see if 512 is divisible by 8. So we divide 512 by 8 in my calculator, and I see that it is divisible, and it comes out to be 8 times 64. And what can I break 64 into? 8 and 8. So you could keep going because 8 is not a prime number, but I have a pair of 4s. So I don't have to exhaust my options here. So what is the fourth root of 4,096?
8.
8. Very good. So this is a fraction square root. So these are actually pretty easy. First thing you want to check is see if the fraction can be reduced. If not, you're just going to take the square root of the numerator and the denominator separately. So what is the square root of 4? 2. But don't forget we're going to do a plus or minus in the beginning of this because it is a positive, an even root. So this is 4 over, what is the square root of 25? 5. Very good. So your answer is plus or minus 2 over 5.
And it's not plus or minus 5, it's odd.
It's not because it's odd, but it's because you only have to do it once, because you don't have to do plus or minus over plus or minus, you can just do it for the whole thing, and that's okay. So for the next one, you can put the negative in the numerator or the denominator. I like to bring it up to the numerator to make my life easier. So what is the third root of negative 1? Negative 1. Because negative 1 times negative 1 times negative 1 is negative 1. Over, what is the third root of 27? 3. Because 3 times 3 times 3 is 27. So something to keep in mind here, this is an odd index, meaning that you don't have to do the plus or minus. So whenever you don't have an index written, like this, your regular square root, that's an implied second index too, whenever you don't have one written. And the next one, anybody know what the fourth root of 81 is? I think we talked about it earlier. This one's going to be plus or minus because my index is even.
3.
3, because 3 times itself 4 times is 81. And then what is the fourth root of 16? 2. Very good. So far so good with you guys? Make sense? Okay. So let's go ahead and try I. So my rule, or recommendation, not really a rule, is to try to divide by numbers 2 through 9 to see what's going to divide. Well, if you do that, you're going to see that this is going to break up into 9 and 13. Okay. Now, is 13 a prime number? Yeah. You can't break it up into anything. Well, you can break it up into 1 in itself, but that's prime. And then what can 9 break up into? 3 and 3. So now we have a pair of 3s and a loner 13. So what is the index of this root? It's just a regular square root, so the index is 2, meaning we have to group things in pairs of 2. So if there's no index here, it's an implied 2. That's just a regular square root. So if my index is 2, I'm looking for pairs of 2. So I have a pair of 3s, group of 2. Anything that gets paired up in that pairing gets to leave as 1 of itself. And anything that doesn't get paired up at all has to stay behind. And just a side tip, if you ever want to check your work to ensure that you've simplified a radical correctly, if it's just a square root, a regular square root, this only works for this. But there's tricks for other ones too. So you actually take this number and put it to the second power, and then multiply it by the inside, and if you get what your original answer is, you know you've done it correctly. So let's go ahead and look at J. So the only difference with J is we have this 4 on the outside. All that's going to do is whatever goes on the outside gets multiplied by that 4. So any ideas on what I can break 320 up into? Well, is it an even or an odd number? So it's always going to be divisible by 2. So I take 320 and I'm going to divide it by 2. And that gives me 160, which I would say is also an even number, right? Break this up into 2 and something. So 2 and 80. And then what does 80 break up into? 2 and 40. And what does 40 break up into? 2 and 20. And then 2 and 10. And then 2 and 5, right? So we have a lot going on here. We have all of these prime factorizations. So, what's the index of this radical? 2. There's no number here, so it's 2. So you're looking for grouping things in pairs of 2. So we have a pair right here, pair of 2. We have a pair of 2. And we have a pair of 2. Anything that gets paired up gets to leave as 1 outside the radical. Now keep in mind, this radical already had a 4 on the outside, so anything we bring out of that radical is going to get multiplied by that 4. So we have the existing 4 that was already there, times this pair of 2 that got to leave as 1, the next pair of 2's that got to leave as 1, and the next pair of 2's that got to leave as 1. So I took all 3 pairs, they all get 1 leaving from that pair. And then what is stuck inside the radical? The 5, because it didn't get paired up with anything. Now your only thing you have to do here is simplify by multiplying these 4 numbers together, and anybody know what that comes out to be? 32. So your final answer is 32 radical 5. Good. Alright, next one. So we're taking the 4th root of 2,592. So, anybody have an idea of what this number could be divisible by? Just using your knowledge here. If it's even, it's got to be divisible by 2, right? So if I divide it by 2, that's going to break up into 2 and 1,296. 2 is prime. And is this number still even right here? Yeah, so it's also still divisible by 2 as well. So this is 648. 648 breaks up into 2 and 324, which is still even, and breaks up into 2 and 162, which breaks up into 2 and 81. And what does 81 break up into? 9 times 9, which 9's break up into 3's. They each break up into 3's. So we have a lot going on here. Bigger numbers are going to have bigger prime factorizations. So we've just done its complete factorization. So this means if you multiplied all the numbers that are circled, you would get the original. That's what the prime factorization means. So we're going to pair up things. But what are we pairing them up in groups of what based on our index? 4. So we have a group of 4 right here. Okay. And then we have a group of the 4 3's right here. You guys see that? We have 2 groups of 4. So anything that gets grouped up in the grouping that we have gets to leave the radical. However, we have this 5 on the outside, just so don't forget, anything we get is going to be multiplied by that 5. So we're going to have the 2 leave from the group right here. we're going to have the 3 leave from this group on the bottom. And then what has to stay behind in the radical? Good, the 2 that didn't get paired up. See this 2 right here that didn't get paired up with anything? That one has to stay behind in the radical. So this answer comes out to be 5 times 2 times 3, which is 30. And then it will be the 4th root of 2. And that will be your final answer. So do you have any questions on that so far? Alright, let's keep going. I can't tell if this is like too easy or if I'm going too fast or what. I'm just going to erase this so we have room. Okay. So the next one we're looking at is the 3rd root of 108. Anybody know what 108 breaks up into? Any ideas? 2 and 54. Any ideas for what 54 breaks up into? 2 and 27, good. And what does 27 break up into? 7. 3 and 9. And then what does 9 break up into? 3s. So we've done its prime factorization. Now what are we grouping things up in groups of? 3 because of the index right here. Okay? So the only thing we have a group of 3 of is the 3s. You guys see that? So we have the existing 3 on the outside that was already there times the 3 that got to leave in the grouping. And then what has to stay behind in the 3rd root? 2 2s. And what do you know, you guys know what you do with the 2s that stay behind? Multiply them. Good. You multiply them. So this comes out to be 9 and then the 3rd root of 4. All right. Any questions so far? All right. Next one we're going to look at is this one right here. So what can I break up negative 250 into? Negative 5 and something else, okay. Oh my gosh. 50, yeah. And what can I break 50 into? 5 and 10. So we'll make the 5 negative and we'll make the 10 positive. So usually make the one negative that isn't going to factor. And then what does 10 break up into? Good, negative 5 times 2. So what are we grouping in pairs of? 3 because of my index. So our answer comes out to be negative 5 radical 2. Not radical 2 alone. I got to put the little 3 there. I forgot. Sorry. So that's a little thing that I forget that sometimes too. If you're doing a 3rd root or 4th root, make sure you put the little number there so you know what the root is of. So you got to keep it consistent with the original problem. So moving on to the next one, we're taking the 4th root of 162. This breaks up into 2 and I believe 81. Yeah. The 2 is prime. What does 81 break up into? 9 and 9. And then all the 9s break up into 3s, right? So I have a 3 that's already on the outside of my radical times, what am I grouping in pairs of this time? 4s. These get to leave as 1. And then what has to stay behind in the 4th root? 2. So my answer comes out to be 9 fourth root of 2. So far, so good?